Okay, so let's get started. Hello and welcome everybody to our webinar today here at Fronius. So, what do we talk about today? Today we want to talk about the Ohmpilot. Sorry, just a moment. Audio. Okay. Yeah. So just a little check. Can you guys hear me well? Could you please give me a hand sign if you can hear my voice? Yeah, okay, I can already see the hand signs. Okay, fine. Thank you very much. Apparently there is a problem within our system here, but it looks okay. So I will now continue. What do we talk about today? We will talk about the Fronius Ohmpilot, all the applications and all the wiring that needs to be done. And so before we start now, I quickly just want to introduce the team for today. So my name is Christoph Schirlinger. I'm a trainer here in the Solar Energy Division at Fronius, and I will guide you through this webinar today. And next to me, you already heard him, his name is Hans Pelzer, my colleague, and he's also a trainer here at Fronius, and he will he's responsible today for the chat. So if you have any questions, on the right side of your screen, you have the ability to send us questions. So if you have any questions, don't hesitate, just send them through, and Hans tries to answer them as quick as possible. And yeah, at the end of the webinar, we also have a few minutes time to answer a few questions live, so you all can hear them. And after that, we will just turn off the microphone and still stay online for you. So if there are any questions at the end of the webinar, we still can answer them right away. Okay, so with this settled, let's get started now. So a few words for the agenda. We will talk about the general product information, of course, for the Ohmpilot today. We will also talk about the applications with the different heat sources, just like hot water generation, the control of heat pumps, the combination with battery storage systems, and also we can apply infrared heatings. So we will also take a look at that. Then we will look at the installation and commissioning process, and at the end we will do a short summary for you. Okay, so the Fronius Ohmpilot. This product is basically a higher for a higher self-consumption rate, and it's doing it by a stepless control of heating sources. So this product is communicating with the Fronius inverter. And only the surplus energy that is within the system in the household is sent steplessly to control the heating source that is connected. And the applications, you can see it down below, can be heating rods in boilers for storage. It also can be infrared heating panels, towel dryer, or any other ohmic load. So for a little bit better understanding, we have here a configuration scheme for the components. So we have on the top left corner, we start with the Fronius inverter with a data manager 2.0. We have a smart meter on the feed-in point, and also the Ohmpilot, and there is connected a heating rod into the boiler, and we also have the temperature sensor. So in this scenario here, we have a production of our PV solar generator of 1.5 kilowatt. And in our household, we have a load of 1 kilowatt, let's say. So we have a surplus energy of 500 watt that's usually just sent into the grid. But we want to avoid that because we have a very low feed-in tariff, or we have a feed-in limitation, for example. So we want to use these 500 watt, and we now can send, so the Ohmpilot is connected to the inverter, and these 500 watt will be sent to the heating rod, and hot water will be generated. So we only use the surplus energy in this scenario. So what are the advantages then by the Ohmpilot? So on the one hand, of course, we have the stepless control from 0 to 9 kilowatt. So it can be either a one-phase heating rod up to 3 kilowatt or a three-phase up to 9 kilowatt. And we can control 1 or 2 heating rods with this product. And it's also very cool because we have an easy visualization over our online tool Fronius SolarWeb. We will take a look at that in the next slides then. Yeah, we also have different options for the communication. So it can be either done over Wi-Fi, over LAN or Modbus RTU. And last but not least, we are also EMV, so in English it's EMC, electromagnetic compatibility. So we are a conform, norm conform in this area. So it's a clean and noiseless control of the ohmic loads. Okay, so just a few words for the wiring. So this would be when you unscrew the top part of the Ohmpilot, you will see this kind of scenario here. So in the top part, we can see the 3 LEDs, the lightings. We can see a button on number 4, the LAN termination, the termination for the Modbus communication on point 6, and on point 7 we have the temperature sensor, a PT1000, that would be connected on this termination here. And on the top part, the lower part, we can see now the for the cabling. So on point 8 we have the input. So it can be either a one-phase or three-phase. In this scenario, it is one-phase. And then on point 9, 10, and 12, we have the 3 phases for the output to the loads we have connected. And yeah, point 12 is here the only phase, so to say, which is continuously adjustable from 0 to 3 kilowatt. So the other phases 2 and 3, so point 9 and 10, are just switched on or off. And point 12 is adjusted according to the surplus energy there, so continuously adjusted. Yeah, we also have on point 11 here the multifunctional relay output. We will also talk about this in more detail in the later slides. But basically what we can do with this one, we can connect a smart grid ready device, so like a heat pump or air conditioning, for example. And with this output we can, according to the surplus energy we have, switch this load we connected to this multifunctional relay. So what we can also do with this, we can connect the second heating rod and do the changeover between the 2 rods within the Ohmpilot by this relay. This is another very interesting thing with this solution here. Okay, so yeah, before we start now with the first application, which will be the hot water generation, I would like to do a short poll with you. So now on your screen you can see a short question, and I would really appreciate it if you could answer the question. So the question is, what load would you prefer to control with surplus energy in your country? So what is what makes most sense in your country? Is it the room heating with the heat pumps? Is it the room heating with electric heating, like infrared panels or something else? Or is it the space cooling, so air conditioning, or simply the hot water generation, so a boiler and we have the heating rods inserted? Okay, Very good. We are almost done, so almost everybody selected here. I will just wait a few seconds longer so everybody has the chance to vote. All right. Another one. Perfect. Okay, I will now close the poll and show you the results. So as you can see, we have 60% voted for the hot water generation. So I guess the what mostly makes sense is the boiler, and we just insert a heating rod and therefore use the surplus energy to power the heating rod. Then we have 20% for the space cooling, so air conditioning, probably in hotter countries maybe, and 20% for the room heating with the electric heating, so like infrared. Okay guys, thank you very much for voting. We will now go back to the PowerPoint. Okay, so the first application with two heating rods, you can see here now the schematic. In this system could be a water tank, 200 up to 500 liters. We have also inserted one temperature sensor, which is connected to the Ohmpilot, and we have two heating rods. So of course, the bigger the boiler is, the more volume it has, the more it makes sense to use two heating rods. And in this case, we have the first heating rod on the top. So this one will be powered first with the surplus energy. And after the temperature is reached, so according to the temperature sensor, then the inserted relay switch we talked earlier will switch off the first heating rod and switch on the second. And then the rest of the surplus energy will be sent to the bottom of the boiler and heat up the rest of the tank. We also have a main heat source in this system. So in areas like here in Austria, the winters are a little bit colder, so we don't have so much surplus energy, not so much sun. So in this time of the year, we need a main heat source for the minimum temperature. So it can be a gas heater or a heat pump or whatever heat source you have. And in all the other months, so from April, let's say, until October, something like that, only the surplus energy by the PV can be used for generating the hot water. Okay, we have now two production curves of a sunny day, let's say, and these visuals you can see here are screenshots from the online tool Fronius SolarWeb actually. So on the left side we can see a very sunny day, the production curve with the green area here. Everything that is green here is power that is surplus energy and sent into the grid. The gray line is power that is directly consumed within the household. Sorry. And we can see there in the red line we have an electric boiler. And with the night tariff it's just switched on during the night and is responsible for heating up the water. We can also see the temperature of the boiler with this blue line. Yeah, this would be the first solution, of course, but as we can see here, a lot of power sent to the grid, not very good, and we don't have a very high self-consumption either. So on the right side we have an electric boiler with an Ohmpilot. So all the area that is blue here is basically the energy that is sent to the Ohmpilot, only the surplus energy, for heating up the boiler. So we have a very increased self-consumption in this scenario. Over 11.3 kilowatt hours are used there for generating hot water, which is a lot actually. So we have a very high self-consumption of 42% or more even. And yeah, why did it stop there on noon? It's because the hot water temperature was reached, so it was switched off. and then during the day it slowly shrinking. So maybe someone was showering, and in the evening, 16 o'clock or something, the Ohmpilot started again to use the rest of the surplus energy to power up the boiler again. Okay, so this would be one type of application. Of course, for putting in the heating rod, you have to have a free slot on the boiler. If you don't have a free slot on the boiler, there are also applications with this flow type heater, so external heaters, where you don't have to screw or fix the heating rod inside the boiler. So with this type, this heating rod from 6 to 9 kilowatt, you could do this externally. So you're also connected to the Fronius Ohmpilot, and would be also possible to do so. Yeah. So, okay, the second application would be then the control of the heat pump. So, what you can see here is a screenshot of the web interface of the Ohmpilot, so where you can do all the settings. So in this case we can see heater 1, so there is a single phase heating rod installed, and on heater 2 we can see we can select there a SG ready heat pump, and we also can set there the starting threshold and the switch off threshold. So until 3 kilowatt, the surplus energy will be sent to the one heating rod that is connected to the one phase heating rod, and after and over 3 kilowatt, the SG ready heat pump will be switched on, and only this would be powered then. So in the next graphic, of course, we can see the production curve again. Left-sided, we also have this daily production curve with a heat pump at fair weather. Now it's turned on during the day, so that we can use the surplus energy. And we can see that we have an increased self-consumption of 10%, about 10%. And on the right side, we now have the combination with the one-phase heating rod, and we can see there all the blue area is used by the Ohmpilot, so by the one-phase heating rod, and we have a higher increased self-consumption of about 30% or higher. So again, this would be a very good solution for increasing self-consumption and not to feed in the surplus energy. Okay, the third combination would be then the battery storage. So we still have this unit with the Fronius inverter, in this case a Fronius Samo hybrid, because this is the one we can connect the battery to it. Then we have the Fronius smart meter on the feed-in point, of course, the Fronius Ohmpilot, and then we have 3 types of compatible batteries right now. Here on the picture we can see the BYD battery, but it could also be a Fronius solar battery or an LG Chem Resu. And yeah, we now have the possibility to sort the surplus energy and either put it into the battery or into the Ohmpilot. So in the next slide, we can see the prioritization that can be done individual on the inverter itself. So in this case, we say, okay, so the first priority is the Fronius solar battery. We want to charge up the battery first with the surplus energy. Then second, we want to generate hot water with the Ohmpilot. And third, we want to switch on the digital outputs we have on every inverter. So right now we have 4 digital outputs where we can connect, for example, air conditioner, heat pumps, big loads like a wall box for EV charging, something like that. And this would be the third priority in this scenario. But it can be mixed according to your needs. And then we have, of course, the production curve here, where we can see we don't have so much green area right now, so we don't have so much feed into the grid. So the yellow area would be all the power that is sent to the battery for charging up the battery. All the blue line again is the power, the energy that is sent to the Ohmpilot. And what we can also see when we have a battery connected in the system, this yellow line we can see here. So this would be the state of charge of the battery, where we can follow the line. Okay, on this time of the day we are fully charged up, and then the inverter switched over to the Ohmpilot for generating hot water. So in this case we would have 9 kilowatt hours storage in the battery, 11 kilowatt hours in the hot water, which is quite a lot. And we also power the other loads by in the household with 6 kilowatt hours and only have a feed-in power of roughly 1 kilowatt hour. So if we compare it to the first one, where we had mostly feed-in power, this looks much better if we have a very low feed-in tariff, for example. Okay, so last but not least, we also have the application with the infrared heating. Suitable heating systems. We can see in the picture something like electric floor or wall heatings that can be installed, or infrared heating panels that can be connected. And usually what's done is there are usually two types of installations you can do. The first one would be the auxiliary heating solution for transitional period. So like you can see here in the schematic here, we have 3 rooms with each 20 square meter, and in each room we have one infrared heating panel with 1 kilowatt. So this is because we have a maximum of 3 kilowatts that we can install on the infrared side. And we also have one reference sensor for the room temperature. So this would be the first solution where we directly control these infrared heatings and only use the surplus energy for heating up the room. So for example, during the day where we have sun, the surplus energy sent to the infrared heatings. This will heat up the room, and in the evening when we come back to the room, it's still a little bit warm because the walls absorb, of course, the heat, and yeah, it's a warmer feeling. That can be used, of course, like it says in the title, in the transitional period mostly. And the second option would be the infrared is the main heating system, so it's not controlled by the Ohmpilot itself, but by another system. And the Ohmpilot is basically just for generating the hot water and is controlling the infrared panels by switching on the relay output on or off. So this would be the second example. So in the next slide we can see there, for this second example I just mentioned with the main heating, that is the infrared panels, we have a room temperature of 20 degrees in the morning, and at about 10 o'clock or something we have reached the 3 kilowatt of the switch on threshold. So the Ohmpilot switches on the infrared panels, and they will use the surplus energy to heat up the room. So we can see this by this blue curve, the increased room temperature of about 24-25 degrees. And on 2 p.m. or something like that, we don't have enough surplus energy and they will switch off, but the room temperature is only slowly decreasing. So by coming back at 5, half 6 in the evening, there is still a higher temperature in the room than in the morning with the 20 degrees. So because of the storage of the heatings within the walls, within the floor, it still remains a little bit warmer then. Yeah. Okay, so a few words at the end for the commissioning. When we look at the installation, what do we need to look out for? So we have these distances here. So to the corners, to other walls, or to the inverter itself, we need to remain a distance of about 20 centimeters. Also on the top, about 15 centimeters. The ambient temperature we can install this device is from 0 degrees Celsius up to 40. And the humidity from 0 to 99%. It's not that critical. And we have a protection class of this device by IP44. Yeah, and another thing that needs to be considered is the distance to the load itself. So from the Ohmpilot to the heating rod or to the infrared heating, it should be not longer than 5 meters. It's because of this electromagnetic, because of the EMC's regulations that we don't exceed this 5 meters. That's the reason why. Yeah, and if you're interested or installing one of these products soon, feel free to click on YouTube. We have an installation video there. You can tune in and watch this video for more detailed installation. Okay, for the wiring diagram for 2 heating rods, we can see this schematic here now. We have okay, maybe just the most important parts. On number 4, we can see here this multifunctional relay, which is responsible for switching from the first to the second heating rod. So with number 9 and number 11, we have these heating rods. The first one is a one-phase heating rod with 3 kilowatts. The second one a 3-phase, and it all can be connected inside. It's just that the first phase output of the Ohmpilot is connected to this multifunctional relay, and from there we either switch onto the heating element number 1 or element number 2. So either one of the heating rods will be supplied by this first phase, which is regulated by the pulse width modulation, so it's the stepless control for the first phase. Okay, so this would be for the 2 heating rods. Here would be another wiring diagram for the control of a heat pump. So again, we have a one-phase heating rod inserted at the bottom here of the boiler, and we have a smart grid ready heat pump inserted, which now is connected to this multifunctional relay. So if, as I told earlier, if a certain threshold is set, then the relay will be switching on the smart grid ready heat pump, and the heat pump would be powered, would run, so to say. So if you have more questions about these diagrams, you can also find them on the right side of your screen under handouts. I have inserted there 2 documents, and one of them is this a document of the Ohmpilot where all the wirings are visualized. So please feel free to click on it and have a look. So, okay, one last thing, the communication, of course. I mentioned it earlier, we have 3 options here. The first one would be the Modbus RTU, which is directly connected to the inverter and the smart meter. The second one would be Wi-Fi or LAN connection, which will be done over the router itself. And yeah, on the bottom we can see there we have these the Modbus communication with D+, D- and ground, which will be also connected on the Ohmpilot. And please also take in consideration this termination resistor. So if this is a Modbus communication, you have to activate the termination on either end of the communication line. So in this case we have it here. On the smart meter we need the 120 ohm resistor, and also on the Ohmpilot there we have a little dip switch. The the one on the far right, and this switch needs to be on the top, and then the resistor is on. Okay, when we have a look on the display, when the Ohmpilot is closed, we have these 3 LEDs I mentioned earlier. So the green LED is for the status, for the mode of the heating rod. So the faster it blinks, the more power is running over the Ohmpilot. And with the blue LED, we can see the connection status. So if the Wi-Fi connection is set up or not. And of course, with the red LED, there is an error, which we can see then in the web interface. We also have the one button in the middle. There are also the writings next to it. So press it once, you have the YPS function, where we can connect it to the router. Then we have with 2 pushes, with 2 pushes, we have the access point opened, where we then can connect with a laptop or a tablet. And when we press it 3 times, we have the boost function activated, and which means that for 4 hours straight, the heating that is connected will run on full power. That is possible to run for this heating. Okay, so when we then connect to the web interface, we do it in these 3 steps. You can see on the left side. So the first one would be to open the access point with the button, press it 2 times. Then you can connect with the laptop or the smartphone, tablet, whatever. And the third step would be you go into your browser and then type in http://ohmpilot, and you will then come to this screen you can see here. So this would be the starting site, and what we can see here is the status. Is it okay, or is there any error in the system? If a temperature sensor is connected, we can also see the temperature and also the heating output that is currently running over the Ohmpilot. Yeah, when we click on General, it's the general settings we can do here. Also for the external sources and heating rods. So as I mentioned earlier, we have heater 1 and heater 2. We can choose there between single or 3-phase heatings, or also if we have active external sources or SG-ready heat pumps. That can be all selected here for the heater 2, and for the heater 1, it's, as I mentioned, single-phase or 3-phase. Yeah, we also have a few options if we have a temperature sensor integrated. We have these 4 buttons, so Legionella prevention. Also, we have the maximum temperature we can set here, and we also can adapt day curve, so where we can set a minimum temperature for a specific time during the day, where we absolutely need the hot water in the morning because I want to shower there. We can set there from 4 up to 6 in the morning. I want to have 50 or 60 degrees in my boiler. Then the Ohmpilot will switch on the heating rod during this time. So please take in consideration, if you set any of these daily curves, there will be energy taken out of the grid. It's not just the surplus energy anymore. But if the customer says, yeah, no problem for me, I want to use the Ohmpilot for the daily production, also during the winter, this could be set here. Yeah, a few words for suitable heating rods. What can be used there? The only thing you have to consider, please use only the heating rods with a neutral conductor. This must be carried out, otherwise we can't connect it to the Ohmpilot. It would be destroyed, the whole thing. So you have to use a heating rod with a neutral conductor, and it can be 1-phase or 3-phase, no problem. And we also have no Fronius products, so no Fronius branded heating rods or something else. If you're interested, on the homepage or also in the data sheets you can find in the handouts, you will find a few names which we recommend, which you can use, but usually everything can be used there unless there is a neutral conductor and there's no power electronics inside the heating rod. Okay, so for the summary, this is the last point now. What are the main advantages now of the heating with PV power? So first of all, it's an easy solution for retrofitting. So also for the electric hot water boilers, if you have a free plug, you just insert it, connect the Ohmpilot to it, should be fine. Also, if you use the infrared panels, you don't need to do the additional water tubes, of course. Also the economical side, you can save the heating material. If you use pellets, gas, oil or whatever, you can save this and use only the surplus energy. It's also that you save or you have a higher lifespan of your main heating source, especially when you use a heat pump, for example. And we also have less maintenance with this product. Yeah, also the highest self-consumption, of course, because we use only the surplus energy. And another point is the low investment costs. So in comparison with solar thermal systems, we have a very low investment cost there. And also when we compare the infrared heatings to other heating sources, this is also a little bit less in the price. Yeah, of course, we don't have any emissions there because we only need the power of the sun in this case. And last but not least, we have one supplier. Every product except the heating rod, of course, is produced by Fronius. So if you have any problems, just contact the tech support, the hotline, and we will try to answer you as best as possible. And also we have the online tool Fronius SolarWeb. So especially for the customer, it's very easy to see how much energy did I use for the Ohmpilot, how much self-consumption did I have. Okay, so I think we're done now. I would now ask my colleague Hans if there are any questions right away we can answer maybe live.
Yes, Christoph, there have been a few questions about the Ohmpilot. Especially one question was if we can add also more than one Ohmpilot on a system, and we have to tell you so far that's not possible, but we're working on that. So at the moment we can't tell you when this will be realized, but we're working on such a solution to be able to run more on Fronius Ohmpilot with one system, more or less. What we can offer now is 18 kilowatt solution, so we have the possibility to connect a second 9 kilowatt heating rod on this conductor, you know, this relay contact from the Ohmpilot to switch over, and then we can also add a second 9 kilowatt heating rod in parallel, so then you have two 9 kilowatt at the moment. And therefore we have also a white paper on our web page. So if you just type in Ohmpilot 18 kilowatt, then you will find this white paper. And then there was another question which is, I think, very important too. It's about the heating rod which can be used. Make sure that the heating rod is, if you use a three-phase heating rod, that the heating rod is supplied with 230 volts. So you need as well a neutral connection. And the heating rods must be connected in a star, as you know. So the star point, you connect your neutral, and then the three phases at the end points of this star. If there is any other triangle connection, then you can't use these heating rod for this solution because we need 230 volts connection. Also make sure that there is no electronic active electronic in the heating rod, because of course with our PWM signal or output we would not be able to supply any power or electronic in the heating rod additionally for any additional active electronic circuit. So therefore please use just the easy ones, the simple ones. Good. So that was the question so far.
Okay.
I think we stay online. We still continue answering your questions. For the moment, that's it. Yeah?
Okay, thank you very much. Yeah, as Hans said, I would now just turn off the microphone, and yeah, we still stay online to answer your questions now in the chat. And yeah, all left to say is thank you very much for listening, and see you next time. Bye.
Bye-bye.